Should we experiment on the human genome? The answer is yes, under special circumstances. Genome editing should be allowed to continue as long as it is used to optimize healthcare and treatment for people with disruptive and life-threatening conditions. As you can see on this graph, the two leading causes of death among Americans are heart disease and cancer. One of the factors which determine whether or not an individual will be afflicted by one of these is the genetic history of one's family. By eliminating this factor, you can expect higher life expectancy and to see these diseases decline as time goes on. So the question is, can we change the projected outcome for people with higher chances of inheriting genetic issues, i.e. can we stop the fire before it spreads? Thanks to the CRISPR-Cas9 gene editing system, the answer may be yes. Various hurdles, legal, financial, or otherwise, will slow CRISPR's deployment. But with regular use in patients, almost all hereditary diseases can be cured in a matter of decades using this system. Before making an informed decision about what CRISPR use should look like, you must first understand how it works. CRISPR isn't just a nickname for the most efficient gene editing tool. It's an acronym meaning clustered, regularly interspaced, short palindromic repeats. It works using a specialized enzyme paired with a guide RNA to locate a specific target sequence, which, once located, it will alter the DNA by making a deletion or insertion. This will result in permanent or semi-permanent changes to the cell. CRISPR's application spans across multiple industries, not only being able to be used to correct genetic mutations, but also to produce biofuels and to produce disease-resistant, drought-resistant crops that produce high yields. Referring to the chart of the leading causes of death shown earlier, 8 of the top 10 causes of death can be reduced or eliminated using gene editing. The tool's application applies well beyond life-threatening conditions. CRISPR can help millions of individuals afflicted with ADHD, colorblindness, factor V, and autism, to name a few. But its exciting potential is overshadowed by its restricted use in many countries around the world. Many countries have outright banned or set tight restrictions on CRISPR use, with the U.S. possibly being the most liberal with its application. Many clinical trials are currently underway in the U.S., fighting sickle cell disease and genetically influenced obesity. Certain countries such as India, China, and Canada have put strict bans on genome editing. This may not be effective as CRISPR deployment ramps up. With hundreds of thousands of individuals coming to the U.S. for healthcare treatment, it is not hard to imagine them coming to the U.S. to receive gene editing before returning to a country where CRISPR use may be illegal or restricted. Despite whatever government rules are in place regarding gene editing and its applications, within any given country, there are always going to be multiple perspectives for and against gene editing. The decision of whether or not to use gene editing is a relatively new debate. This means that not many people are going to have a clear enough understanding of how it works. Thus, numerous people on all sides of the political spectrum aren't going to be able to make an informed decision on this issue. The issue of gene editing isn't deeply rooted in liberal or conservative policy. Rather, people will need to think about how this will affect society in years to come. A poll by Harvard University in 2016 showed that 26% of adults thought changing the DNA of unborn to reduce the risk of disease is acceptable, with even fewer adults saying it should be done for cosmetic reasons. This has changed in the past few years, likely as people become more and more educated of gene editing and its potential. A study done later found that 72% of adults said that changing into a baby's genes at birth is acceptable. The reality is that correcting genetic mutations in the population will lead to a more comfortable life, with the well-being of the world's population improving over time. The future of gene editing is bright. It can be used across a myriad of industries. It can prevent people from enduring disruptive diseases and conditions. In the near future, gene editing tools can help a lot of people. They just need to be carefully implemented to correct the health issues that face the world's population. As long as it's being used to enact positive change, there's no reason experimenting on the human genome should not be pursued.
How did your research question evolve as you moved through the research process?
Well, my research stayed mostly static, but the information I found allowed me to stay with my original research question.
Okay. What additional questions emerged from your research, and why are they important?
One question I had as a result of my research is, what are the long-term effects of gene editing? I thought this was significant as it would allow me to understand what questions other people might have that are doubtful in the process.
Okay, thank you. Another round of applause.